solve a LeetCode question. So question number is 1, the very first question of LeetCode, and that is do some very popular question. And I already solved this question on previously on my YouTube channel, and I guess this is my first video that I solved this question. But in that I solved this question with a very brute force approach, like using 2 for loop. But now in this video I'm going to use very optimal approach to solve this question. And uh, uh, now the description is given an array of integers nums and an integer target. Return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So this is a very popular question, and you guys all know this question. And from using brute force, you already solved this question. Now today we are going to talk about the very optimal approach, like in order of n squared, order of n time complexity, and the constant space complexity uh, to solve this question. So in example 1, we have the nums array that contains 2, 7, 11, and 15, and target is 7. So we need to find that which two elements from array we can take and add them to get the target equal to 9. So if we directly look at the nums array, then we can see that if we took 2 and 7, then if we add both, then 2 plus 7 equals to 9. So we can say that on the index of 0 and on the index 1, we have two numbers that can add up to the target. So we return 0 and 1. In question, they says that each nums have exactly one solution for target. So we doesn't need to get the another two indexes to find the nums, find the target again. And also we cannot use the same index twice. We can use an index for the only one time. So this is the question, and there are some constraints like nums of length can be this, and nums of I can be very big range, and target is also can be in very big range. Also, they say that only one valid answer exists, and follow up that says, can you come up with an algorithm that is less than order of n square time complexity? So here they clearly say that we not going to use the 2 for loop approach that have the order of n square time complexity. So now I will tell you the basic overview of the solution that we are going to use here. So for the optimal solution of this question, we are going to use unordered map, because in C++ or in STL library, unordered map is a data structure that have the order of n, means the constant time complexity for the search operation. So for that big reason, we are going to use order of unordered map to solve this question. So in our solution, what we are going to do is, first of all, we run a loop through our nums array, and in that we minus each of the number from our target. So after doing this, we are able to find that if we minus one number from our target, then we get the second number. And after getting that second number, we can say that if we plus the first element that we minus from the target and we get the second element, if we add up both, then it equals to our target, right? So what we do is we minus each numbers from nums from the target and store that value in our unordered map along with that indexes, means that index values. For example, the first element is 2 and target is 9. So if we minus 2 from the 9, then we get 7. So we store 7 in our unordered map with index 0. So 7 and 0, that is the correct way to store in the unordered map. And after that, we check in each iteration in unordered map that the value that comes after the subtract element from target is already exist in unordered map or not. If it exists, then we directly return the exist values index and current values index, right? And we all know that there is only one solution exists. Then after getting that one solution, we push that both indexes in another vector or array, and then we return that vector, because here the function type is vector, so we need to return the answer as vector. So now I write the code, and then I will explain you that code with the perfect dry run with any of these examples, that you can get a better clarity. So let's write the solution code. Okay, so first of all, let's define a unordered map. So for that, I'm going to write an unordered map as both value of int, and let's say we give it a name as pairs, etc., anything like pairs. And after that, we need to uh, declare a vector int with the type integer, vector answer with the type integer. After that, we run a for loop to travel on each element from the nums vector. So for that, let's run a for loop from I0 to nums dot size and we plus it. After that, here we have the if condition, that this if condition is for that if we find the element that is already existing on ordered map. So first, for now, we write it after this step. So first we declare here is if this condition is not followed, then what we're going to do is we directly add uh, pairs of num I equal to I. So what this line does is this nums of I means, for example, if we say nums of I is 0, so pairs of 2 becomes 0. So means the 2 index that is stored in unordered map pairs, that index becomes 0, right? So because we need to return the indices of that two number that get that the target after they plus, so we need to store that indexes along with that number in pairs. That's why we are going to use unordered map, right? So now for the if condition, we are checking that if for pairs dot find and anything like c, if is not equal to pairs dot and, then what we are going to do is we are going to push back uh, we're going to push back pairs of c, and also we are going to push back the also, right? Now what is c? So the c is target minus nums of I, right? So C is the integer that we find on each iteration after minusing it from the target. So, and after this for loop, and here we are going to return this answer vector. So this is our full code. So first, let's run it. If it's work, then I will explain you it with a proper dry run. So the all three test cases are passed. So now let's move on the other screen and I will explain you it with dry run. So now I'm on the second screen to dry run the code. So this is our code that we write, and this is the example one where this is the nums array, right? So now let's dry run the code. So for the first two line like unorderd map and vector that create this type of something visualization. We can say visualization in backend. Like this pair is an unordered map that have two positions, and this answer is a vector. So now the for loop runs from 0 to num size means 0 to 4 means total 4 times. So first iteration for that I is 0. So for this first iteration, for I equal to 0th iteration, c equal to our target minus nums of 0 because I is 0. And so that's why our c becomes 9 minus 2 equal to 7. So for this first iteration, our c value is 7, right? So now this condition not follows because this condition is definitely not followed because for the first iteration means I equals to 0 in our pair is empty, right? So in that there is no any uh, input. So because of that this is not works, this if condition not followed. So directly in pairs we add this 7 this nums of I with along with that index. So our nums of I is means our this nums of I zeros value we have is, but we have the exact value of this is 2, right? Because our first index in our nums array is 2. So pairs of 2 becomes I, that is 0, right? So in pairs, here we can say here 2 comes and 2 stored here, and here also 0 comes and it stores here. What it says that we are try to store the both of element like 2 and along with its index because we need to return the index. So this particular line work like this because works like this means the current element of nums array stores along with it index in pairs unordered map, right? Now let's move on the second iteration. So for I equals to 1, what we here is our C becomes something different. So for this iteration, our C becomes again target, there is 9, and nums of 1 that is 7 because second element is 7. So this becomes 2. Now our C becomes 2, and now because our unordered map is not empty, there is one element in that. So this if condition follows, and what this if condition check is if we are able to find the C in pairs array, in pairs unordered map. If yes, then do this two task, right? And if we are not able to do that, then add that element along with its index in pair unordered map. So this particular line means it in the if condition, this checks that if here C equals to 2, right? So it checks if we are able to find C in pairs array. If yes, then follows this, or if not, means pairs of and means if we are if we are checking the whole pairs unordered map and we arrive at the last position means the end of the unordered map and still we are not able to find that C in, so that means the C means the number is not stored in unordered map, means that number is unique, totally unique, right? So this condition is totally for that. Now here we have we2 is already in our pair unordered map, so C is existing in our unordered map. So what this this condition follows definitely. So what this operation does is, in our answer array, it push backs pairs of C. Now pairs of C gives us as the index of element. That means if we are going to finding that like pairs of C becomes 2, so pairs of 2 gives us 0, because in our unordered map we store 2 along with 0. So pairs of 2 becomes 0 because it gives us the index that it is stored in unordered map. So that's why after this condition we are adding that number along with its original index of nums array or nums vector. So that's why if for example, if we take another example, and if we take like pairs of 11, then pairs of 11 gives us 2, right? Because in nums array the 11th position is on the second index. So if this arrives if in only 11 is exist in pairs unordered map, right? For now it doesn't exist, so this not follows. So this follows. So because of this pairs of C means pairs of 2 becomes 0. So in our after this first line in our answer array, the one is arrived, and that is 2. The one element is already arrived, right? And after that we are going to push back the current index. We are going to push back the current index, and our current index is 1 because first iteration is over, and in that iteration we add 2. But in second iteration we got C as 2, and 2 is already exist in pairs unordered map along with its original index 0 that we find. That's why we perform these two operations, and in that two operation, first we push back 2's index that is 0 in our answer vector, and after that we push back the current index that we are on the current element, and that is I, and that is 1. So after this sorry, here 2 is not pushed, here 0 is pushed, and after that here 1 is pushed. So our answer vector becomes 0 and 1, because here we are going to push pairs of C, and pairs of C gives the index that we store along with 2, and that is 0. That's why in answer vector first 0 is pushed back, and after that the current index that is 1. That's why 1 is pushed back. So why we are doing this? Because we need to find that indexes of the two element that adds becomes target. So first of all we add the original. First of all we add the first C if the unordered map is empty, that we add already here, and that is 2 with along with index that is 0. After that we move on the second index, and that is 7, and we minus 9 minus 7, and it becomes 2. And then we check in on unordered map that 2 is exist on the 0th index. That's why we can say that 2 plus 7 becomes 9. That means 2 is on the 0th index, and because we are our current index is 1, and that is 7, because the current element it adds in the previous that we stored in our map and gets us the target. That's why we can say that first we push back the previous numbers index that is stored in our map, that means 0, and then we push back the current element index that is 1, because the current element previous elements becomes target after adding that. And that's why we push back the both indexes in our answer vector. And after this all we return answer, because our function is in vector type, so we need to return also in vector type. That's why we return answer. So in that way these whole codes work. For now we are able to find the first two element as target, but sometimes in worst case scenario we need to travel the whole array, or the whole vector, whole nums vector. So for that only reason the time complexity of our this code is becomes order of n, because given for loop. And I say that unordered maps searching operations is in order of 1, means constant time complexity. So this whole task is constant. So that's why we are getting the order of n time complexity. Now I hope you understand the code, and I hope you understand the dry run of this code. So let's now move on the our original LeetCode compiler and submit the code, and let's check the results. Okay, so now I'm on the LeetCode compiler, and we already run this code. So now let's submit it. Now as I say, this is our optimal approach. That's why we are getting 11 millisecond. Otherwise we are getting in some this range like in 113, 112, etc. milliseconds to run this code. So now if I analyze the time complexity, then it becomes order of n, and we follow the instruction that is in question, like reduce time complexity from order of n square. So we do that. So I hope you understand this approach also, and if any doubts, let me know in the comments. Let's meet in the next question. Till then, goodbye.